Okay, so next session we will continue the representation schemes that we were talking about. So, we were talking about description logics. So, in description logics you have these these are the available predicates, okay, in the classic language. So, you can use concept, you have a concept name and you use things like and, all, at least, at most, fills, same as, one of, etc. Okay. So, these are, this is the way that the description language actually works. So, what you find is that there are some things which can be represented much easier using description logic, and there are some things which can be represented much easier using the first order logic. Okay, but you can you should be able to translate from one to the other, right. So, you find that in some cases the description logic comes out much more concise and easier to represent in some cases, but in some cases you find that this description logic does not do as well a job as the first order logic. So, let us look at one example here. So, you have to describe the set of men with at least 3 sons who are all unemployed and married to doctors, and at most 2 daughters who are all professors in physics or maths department. You could put it in description logic in this way. So, you are talking about, and you are talking about a man who has at least 3 sons, at most 2 daughters, and all the sons are unemployed, married, and all the spouses are doctors, and all the daughters are professors and they are in the department of physics or maths. So, this particular sentence or concept can be easily described by using the description logic. So, in the first order logic it will be a little difficult to actually represent this. So, what you find is that what we said at the beginning, that is the subsumption checking and classification checking are some things which are done by using the description logic. So, you find that using description logic either hard problems cannot be stated at all, or they require exponentially large descriptions. Okay, so, that is the problem with some description logic. Description logics usually lack negation and disjunction. So, when you are using things like fills, right, some type of negation actually will be taking place there. So, here when we say fills department physics, math, etc. Okay, so, the next category or the next representation scheme we are going to check out is the case frame. So, here this is a verb oriented approach. So, it is a way of representing sentences. So, you take the verb in the sentence and the entire sentence is represented in reference to that verb. For example, you can have a sentence like Sarah fixed the chair with glue. So, obviously, fix is your verb. So, you are going to give the sentence with reference to fix, and then you have these links, and these links will give you some relationship, what are called the case relationships. So, you have things like agent, object, instrument, location, time, etc. So, generally if we look at this sentence, the agent here is Sarah and the object that we are talking about is the chair, and the instrument that is being used is the glue, and the time is the past tense. Okay, so this is a case frame method of representing. So, this is just by the way, just to show you different methods of representation basically. Okay, then we come now to what is called the conceptual dependency, which actually represents the actions in a very like you know, you can understand what is happening, the semantic meaning comes out so strongly in the conceptual dependency. So, this was by a Shank actually. So, you have 4 primitive conceptualization. So, you have things, one is the actions, and then you have the objects, and you have the modifiers of actions and modifiers of objects. So, these are the 4 which are basically involved over here. So, all actions are reduced to one of these primitives. Okay. So, we have how many primitives here? We have 12 primitives here, and any action that you do can be brought down to one of these 12 primitives which is been given here. So, they are A trans, that is transfer a relationship, that is give. Okay. So, you A trans a book to somebody, right. Then you have P trans, that means physical transfer of an object from one point to another. So, it could be things like go from here to there. Propel, propel means apply physical force to an object. So, that is like push. Move, move body part by the owner like kick, etc. Grasp, grab an object. Okay. Then ingest, ingest an object is like eat. Then expel, expel from an animal's body. So, something like cry, you can expel a cry, right. M trans is transfer mental information, that is tell. So, you tell something to someone, right. So, there you use M trans. M build is mentally make new information, that is decide. Then cons is conceptualize or think about an idea. So, that is think. Then speak, produce sound, attend, focus sense organs, that is listen. Okay. So, these are all the possible actions that can be performed, right. And then you have a method of it defines the relationship between the conceptual dependencies. So, the rules are in this way. Okay. So, you have PP. So, PP is what? PP is the, like we said here, PP is the objects or the picture producers, right, and act is the actions. So, it indicates that an actor acts. So, you are going to put it in this way, and this indicates that an object has a certain attribute, and here this indicates that an object indicates the object of an action basically. Okay. Then here this indicates the recipient and donor in an action. So, it is transferred from here to there, right. One is the recipient, this is the donor and that is the recipient. Indicates the direction of an object within an action. This indicates the instrumental conceptualization for an action. In other words, this whatever is here is the instrument, is what causes this action, right. And this indicates a conceptualization X causes conceptualization Y. Or, and if you put C, you could say it could cause, right, conditional, and this indicates a state change of an object from PA1 to PA2. So, it from attribute 1 to attribute 2, and this indicates that PP2 is either part of or a possessor of PP1. So, knowing all these, we can actually write out sentences using the conceptual dependency. So, if you take the first one, John ran, right. So, you have a a connection between John and ran. So, when we talk about ran, we will have to use go, right. So, P trans will have to be used there. So, you will have to say John P trans, and you have to put P, which is a past tense, on this. Then the next one is John is tall. Okay, so, P P, so John height is greater than average. John is a doctor. John is a doctor, you have to put this way, a nice boy. John's dog. So, you have John and you have the dog, and you have this arrow which says possessed by, right. The next one is John pushed the cart. So, you have John, so he used propel, okay, with the past tense, and what was the object? It was the cart. John took the book from Mary, right. So, you have John and you have A trans, and the object is the book, and it goes from Mary to John. So, Mary gives the book to John, and John is the recipient of that. John ate ice cream. So, he ingests, object is ice cream, and what did he do? He used the object and he ate the spoon, and he ate the ice cream, etc. John fertilized the field. Okay, so, again P trans, fertilizer, the object is the fertilizer, and it goes, the manure goes from the bag to the field. The plants grew. So, their size was x before and it became greater than x. Bill shot Bob. So, what did Bill do? Bill used propel of the object bullet from the gun to Bob, and as a result of that you have this conceptualization. Bob's health goes to -10 basically. Okay, in other words, he gets shot, right. John ran yesterday. Again John, P trans, just like we used here, and P because it is a past tense, and yesterday because that is what you need to put there basically. Okay. Okay, so, this represents John ate the egg. So, John ingests, the object is the egg, and it moved from John's mouth to inside his body. Okay, so, something like this. So, very explicitly or explaining what is happening basically. So, here John prevented Mary from giving a book to Bill. So, you are using other tenses and modes here. P is past, F is future, T is transition, okay. K is continuing. Okay, so, continuous tense when you are using. C is conditional, this is negative, interrogation, present, etc. right. So, here John prevented Mary from giving a book to Bill. So, John, what did John do? He prevented Mary from giving the book from Mary to Bill. The object is the book. So, basic thing here is this negation that you have here and the conditional basically. Okay, then we come to the scripts. So, like I said, it gives a stereotypical sequence of events. Okay. And what does it use? It actually is in the form of scenes, scene 1, scene 2, scene 3, and each of those uses the conceptual dependency structure which we just saw. Okay. So, what does the script have? It has all these components. You have the entry condition or description of the world that will be true for the script to be called. Okay. Results or facts that are true once the script has terminated. Props are the things that support the content of the script. The roles, that is the actions that individuals perform. And the scene will consist of a sequence of scenes. The script will consist of a sequence of scenes. So, for example, this is a restaurant script. Okay. So, what do we have here? This is the script which is called the restaurant, and the props that are used here is things like menu, money, check, etc., right, and the roles that are there. The roles are the cashier, the cook, the waiter, the owner, okay, all these are the roles that you are using. And what is the entry condition? The entry condition is that the person is hungry and he has money. And what will be the result? The person has less money, the owner has more money, and S is not hungry and S is pleased. Okay. He may be pleased or he may not be pleased. Okay. So, in one condition the output could be that S is pleased or the person is pleased. And then we have all these scenes over here. First one is entering the restaurant, second one is ordering in the restaurant, third one is eating, and the fourth one is exiting the restaurant. And each of them contains sentences in conceptual dependency. So, basically he goes into the restaurant and then he looks around and then he thinks where to sit, and then he moves to one table and he goes down to a sitting position. And the second one is the ordering. Okay. Either menu is on the table or he may ask the waiter for the menu, okay, etc. And then once he takes the menu, how he orders the food. Okay. He decides what he is going to eat and then he orders the food, etc. Then the eating part, okay, and then how he exits. Okay. He moves to write the check, the waiter, right, and the waiter P trans to S, he comes back, okay, and he offers the check to S, okay, and he transfers money to M, okay. M is the cashier, right, and then he goes out of the restaurant. So, this is the way the entire script is done. Okay. So, whatever script you want, it will be in this form. Okay. So, the next structure that we see is the frames, right. So, it talks about frames which uses what is called the frame theory. When one encounters a new situation, then it goes to the frame to find out information. One selects from memory a structure called a frame. This is a remembered framework to be adapted to fit reality by changing details as necessary, right. So, this was proposed by Minsky basically, right, for understanding natural language. So, what are the slots in the frame? Okay, a frame consists of a set of slots, okay, and the slots will have all these information. First of all, the frame identification information. So, it will have an ID and relation of this frame to other frames. Okay. For example, if we are talking about a particular, say, phone 1 which is in the hotel room, right, it will be connected to the instance of phone, okay, so which will tell you what a phone is, and descriptors of the frame. For example, you may have a chair, you may have a bed, you may have a table, all those things, right, and procedural information on use of the structure described, and the frame default information. These are slot values that are taken to be true when no evidence to the contrary has been found. For example, you will assume the chair has 4 legs, the telephones are push button, hotel beds are made made by the staff, etc., and new instance information. So, these are So, if we look at this frame over here, right. So, you have the frame for a hotel room. So, what are the slots it contains? It is a specialization of a room, and where is the location? Location is in the hotel, and what does it contain? It contains a hotel chair, hotel phone, hotel bed, and so each of them are connected to the frame. Okay. So, hotel chair goes to this frame hotel chair, which is a specialization of chair, and you know what is the height, number of legs, what it is used for, etc. Similarly, hotel phone will go to the frame describing the hotel phone, and hotel bed will go to one describing the hotel bed. And here also, when you talk about mattress, you may have a frame here which talks about what is a mattress. So, this goes to that, etc. So, you can get all information that you require by using this. Okay, so, this is a spatial frame, okay, for you for viewing a cube. So, when you move it, you find that different faces of the cube are coming up, right. So, you can represent it in this way basically. Okay. So, the last thing we are going to talk about is what is called the conceptual graphs. Okay. A conceptual graph is somewhat like a semantic network, right, but you have boxes, okay, and circles, and the arcs do not have any labels basically. So, you have the concept nodes or the box nodes, which consists of concrete concepts, for example, cat, telephone, classrooms, etc., and the conceptual relation nodes. Okay, these are the ellipses or the circular nodes, which talks about the relation between concepts. So, here you have a bird, okay, conceptual relationship, bird flies, right. So, this is a one, it has only one concept basically, and here you are saying that dog color is brown, right, and a child has parents, and the parents are father and mother, etc. So, here you can see that the arcs do not have any label on them basically. Okay. Conceptual graph, concept box with type label indicating the class or type of individual represented by a node, and a label consists of type and individual, or it could be of a specific particular object that you are talking about. So, here for example, Mary gave John the book. So, you have give and the object that is given is the book, and the recipient is the person John, and the agent is the person Mary. Okay. So, basically it is something like what we saw earlier, except that you have these ellipses here which represent the relationship between different concepts which you are using. But what we are going to see here is how it can be used for inference, etc. So, here we are talking about a dog named Emma, okay, and its color is brown. Okay. And you have a dog, a particular dog with a number, and its color is brown. Conceptual graph indicating that the dog named Emma is brown. So, this dog has a name which is Emma, and it has a color which is brown. So, if a person has 3 names, you can also put it this way. So, you have name McGill, name Lil, name Nancy, etc., right. So, the dog scratches its ear with its paw. So, you have scratch, the object is the ear, the instrument is the paw, and the paw is part of the dog, and the ear is also part of the dog, and the agent is the dog. So, this is one conceptual graph. Okay. Okay, so let us see how it does all these. So, you have things like copy, restrict, join, simplify, etc. So, if we look at this, you have okay, so you have a dog. Okay. If you take this third one, it is a restriction of G2, right. So, if you take G2, the color is brown, location is the porch, and the dog is Emma. So, the animal has been changed into a dog. So, that is restriction. And how do you join G1 and G3? Okay, so, you are joining G1 and G3. So, you are saying agent dog, color brown. So, from both of them you are getting color brown, location porch, and eat object bone, right. So, this combines G1 and G3. Okay. And you have something to simplify it. So, how do you simplify it? You can just put color brown, location porch, agent, eat, object bone. So, wherever there are unnecessarily the same things being repeated again and again, you can remove those and you can simplify this. So, in this conceptual graphs, you have things like called restrict, join, and simplify operations, which can be used basically. And inheritance is implemented by using join and restrict. Okay. So, when you say restrict, then the inheritance comes into the picture. So, if you you are going to replace something by something more specific, and some property inheritance is going to be used over there. Okay, so, inheritance in conceptual graphs. Okay, so, if you take a primate, the hand is a part of the primate. So, this is a conceptual graph. Chimpanzee, hand is a part of the chimpanzee. Okay. And chimpanzee bonzo, hand is a part of that. So, basically you are going to replace it by something more specific. So, this is how sometimes the inheritance takes place in conceptual graphs basically. Okay. Now, you can use if you have a proposition, okay, you can represent the proposition in this way, in a box, right. And you can say that for universal quantification you can use this. For example, Tom believes that Jane likes pizza. Okay. So, you are saying likes, agent Jane, object pizza. Okay. So, Jane likes pizza is the proposition that you are represented over here, and then you are saying that Tom is the experiencer of the experience which is called believe, and the object is this particular thing. Okay. So, you could put it in a box in this way, right. You could also do things like using all x here, or a negating box, etc., right, which helps you to use things like universal quantification, etc. Okay. So, here is the negation that we have used. There are no pink dogs. Dog color pink, okay, you can put that in a box, and you can say that you are negating that, right. So, this is a conceptual graph, and you are representing there are no pink dogs over here basically. Okay. So, these were some representation schemes that we studied. So, we will stop at this point and continue in the next session.